Here's a simple experiment. Take an unverified smart contract address and ask GPT-5 the same question 10 times. Is this contract safe? The answers shift. Looks safe. Needs caution. Serious risk. Same question, same model, same code, different answers. That's not a bug. Probabilistic generation is how these models are designed to work. And yet, a growing share of Web3 security is being handed to exactly this machine. This video is the case for keeping it out of the judgment seat. Why does this happen? Large language models predict the next token. A transformer computes a probability distribution over the next word, and samples from it. Setting temperature to 0 doesn't make it fully deterministic either. Floating point rounding, GPU parallelization, batching order, hardware-level non-determinism remains. OpenAI, Anthropic, and Google don't hide this. Their documentation promises only best-effort determinism. LLMs are machines that statistically generate plausible answers. They don't fix facts. For most tasks, that's fine. For security decisions, it's a fatal flaw. Traditional financial audit was built on a blunt premise. Humans make mistakes, people lie, and systems break. On top of that premise, finance built 3 principles. Reproducibility. The same input always returns the same decision, tomorrow, or with a different reviewer. Explainability. You can show exactly why variable A cross threshold X rule be applied. It just feels right doesn't fly. Traceability. When, who, what data, what decision, fully reconstructible after the fact. A decision without all 3 does not pass financial audit. No exceptions. Why so strict? Because systems always break eventually. Keys leak. Internal controls collapse. Employees commit fraud. Programs have bugs. And when something breaks, you need to be able to take the decision apart, otherwise you can't prevent a repeat, and you can't rebuild trust. Now score an LLM against those principles. Same input, different answers, reproducibility, gone. No visible chain of cause, explainability, gone. No way to rerun it later and get the same result, traceability, gone. Financial audit doesn't reject LLMs out of emotion. And this debate is older than LLMs. In the 2010s, deep learning arrived in banking. Vendors pitched neural networks for fraud detection, credit risk, insurance underwriting, always with higher accuracy. Banks didn't put them into production. They were black boxes. Audit departments couldn't approve a loan rejection nobody could explain, and neither could regulators. What got adopted instead? Logistic regression and decision trees. Less accurate, and adopted anyway, because the industry decided, as policy, that explainability beats accuracy. Neural networks survived only in initial screening, generating candidate lists, with the final decision rechecked by explainable models. Layering, not replacement. What banks learned in the 2010s holds up fine in the 2020s. LLMs are more of a black box than those neural networks ever were, and more probabilistic. And yet plenty of security products today market exactly the thing banking rejected: LLM-only risk judgment. So why does LLM dependence keep spreading? The usual answer is cost. Just call an API. That's half the story. The real reason, you don't have to think. Building a deterministic risk engine is work. Bytecode analysis, pattern rules, blacklist checks, score weighting. You design it, verify it, maintain it, and own every error case. Hand it to an LLM and all of that disappears. Write a prompt, call an API, label the output AI judged. Builders, sellers, and users can all stop thinking. Easy now, broken later. When a client finally asks, "Why did you decide that?" an LLM-dependent product has no answer. And when regulators require explainability, it can't comply, in principle. Ninja's answer is a design principle: separate Layer 1 from Layer 2. Layer 1 fixes facts, deterministically. Bytecode machine learning analysis with deterministic feature extraction. Similarity search against a database of 90 million contracts. Function selector and method name mapping. OFAC and blacklist checks. The output is structured, 17 alert codes, 13 intent categories, and a traffic light signal, safe, warning, danger. For the same input, Layer 1 always returns the same output. 100% reproducible. And there is no LLM anywhere in it. Layer 2 is where the language model lives, as a translator, not a judge. It takes Layer 1's structured output and renders it readable. This contract was deployed 14 days ago, the code is unverified, and it's 87% similar to past exploit patterns. It does not change the decision. It only explains it. Court judgments work the same way, fact-finding at the base, legal evaluation on top. If a judge said, "It feels guilty to me," nobody would accept the verdict. This is an old, correct design, brought into a new space. This design comes from experience. I spent 13 years at Accenture on financial AI projects. In the early 2010s, a large bank was building fraud detection. A vendor proposed neural networks, a few points more accurate than the existing decision trees. The audit department rejected it in 30 minutes, with one line: "We can't get approval for decisions we can't explain." What shipped instead was logistic regression with gradient-boosted trees. Slightly less accurate. But every decision carried a reason code, audit logs stayed, and the same transaction rerun a year later returned the same result. In August 2026, the main articles of the EU AI Act enter full force. High-risk AI systems will be legally required to provide explainability, traceability, and human oversight. Security assessment is likely to fall into that category, and systems that decide whether financial transactions go through almost certainly do. The AI judged it comprehensively does not meet an auditability requirement, so LLM-only security products are structurally out. A Layer 1, Layer 2 split bakes the requirement in from day one of design. Ninja doesn't sell smart AI security. It sells verifiable security. The difference looks small, and it's decisive. A smart system gets it right once, but when the 100th answer is wrong, nobody can trace why. A verifiable system returns the same decision on the first try and the 100th. Even when it's wrong, you can see where and how it decided. So you can improve it. So you can learn from it. So trust accumulates. In the agentic era, demanding explainability can sound like imposing human constraints on AI. It isn't. Humans impose verifiability on ourselves not because we're inferior, but because we make mistakes, and keeping mistakes verifiable is the starting point of improvement. Medicine improved through autopsies and case records. Engineering improved through accident reports. Finance improved through fraud postmortems. Law improved through precedent. Every field runs on the same loop: keep failures in verifiable form, then learn from them. AI agents won't make fewer mistakes than humans. They make new kinds: prompt injection, reward hacking, out-of-distribution behavior, unintended tool chains. Throwing away verifiability now means throwing away the feedback loop itself. This is one of the reasons ZKSC exists. Bring the power of new technology and the institutions of old wisdom, not one or the other, both. Layer 1, Layer 2 separation doesn't reject LLMs. It builds them into a verifiable framework. Assume mistakes will happen, and keep verifiability in place. That's 50 years of financial wisdom, and it's the condition for the next 50 years of agentic finance to keep improving at the same pace. If you want to see the split in practice, send any contract address to the Ninjascan bot on Telegram. You'll get Layer 1 structured signals, plus Layer 2's plain language explanation. If you run a DeFi protocol, or you're an institutional investor who cares about explainability, ZKSC is looking for proof-of-concept partners. Chapter 5 of the Ninja White Paper covers this design in detail. The era where AI makes every decision isn't coming. The era where LLMs write every explanation is. Keep the roles separate, and the technology lasts.